Power reducing formulas, and the half angle formulas. Now, all of these are in the textbook in section 5.5. Now, there's more than just these, and there's a whole lot of them in the front cover of your book. Let me show you those. Inside the front cover, where you have the unit circle and the basic triangles and stuff, you got all that. There's also all these other identities. Now, a lot of them are useful. There's more than I'm going to ask you to memorize. It all sort of depends also on your calculus teacher next year. But if they're important enough to be in here, you're probably going to need to use them again and again and again and again. So, like I said, some of them you just have to memorize, but a lot of them, if I can generate them from another one, that's what we want to do. And that's what this video is about. Alright, so what we're going to do is we're going to start with the sum formulas and walk our way through all of them. And here's how this goes. I remember it as cosine, cosine, sine, sine. Like disco, disco, good, good, cosine, cosine, sine, sine. There was a skit on Saturday Night Live a long time ago with disco, disco, good, good. Anyways, the point is, it doesn't have to be U and V. It could be X and Y. It could be A and B. It could be whatever. Different books use different things, but the variables just go in the same order. Now, the double angle formula says, what's the cosine of 2u? Well, 2u's would be u plus u, which would be cosine u, sine u, sine u. All right. Cosine, cosine would be cosine squared u and sine squared u. We could do that because it's the same thing times itself twice. Up here, u and v, you can't do that. But cosine u is cosine squared u. So u plus u, this is the same as cosine of 2u. This is our double angle formula. So you don't have to memorize this if you know this. Okay, one less thing to memorize. This leads into the other form. Okay, and that's what we're going to do right now. Now, it's going to be important that you recall the Pythagorean identities. So here's the Pythagorean identity, if you've forgotten it. Now, what they do with this is a starting point, and if you subtracted cosine squared from both sides, you would have a new version of this formula. Let's do it right there. Let's say you subtract it from both sides. Well, on this side it cancels. This side doesn't cancel, and you get, this is our new formula. Okay? It's not as famous, it's not as easy to memorize that, but it's a different version of this. It's just we subtracted cosine squared on both sides. How is that useful to us? Well, check this out. Now we can take this whole thing and plug it in here instead of sine squared. So our original formula up here, let's rewrite it now down here, becomes this. Cosine 2u, cosine squared minus, so that's all it is this one, but instead of sine squared u, I replaced it with this thing. So that was our original formula from before with this replaced instead of sine squared. So now we're going to take this, and this is going to be our starting point for going forward. Alrighty. That's how this sort of goes. Okay, so we're just pushing around a lot of algebra here. And so the minus goes to this one and to this one. So you get cosine squared u minus 1, and then a minus minus becomes plus cosine squared u, which becomes 2 cosine squared minus 1. We took this one and this one. They're both the same, and we have two of them. So there's one of them, there's one of them, there's two of them. And that is now your new formula for cosine of 2u. Okay, so that's another way to write cosine of 2u. Now, if we push this thing around, we could solve it for cosine squared. Let's say we want the cosine squared alone, and we could do that by adding 1 to both sides and solving. Let's do that. Plus 1 to both sides looks like this. The 1's cancel. These do not add, so it's cosine of 2u plus 1. And finally, if we want to get cosine squared alone, we'll divide by 2. Now, these 2's do not divide. This 2u is inside of the cosine operation, so it does not divide. But these ones divide. They're outside. It's 2 times cosine. It's just 2 on the bottom. Those divide out. And now you get cosine of squared of u equals this. And we can leave it like this, or you can put the 1 in front. It's the same thing, but that is now, if we put this in reverse order, this is a new formula. They usually put cosine squared on this side, and then this on this side. And that's your new formula. This is called the power reduction formula. So we went from a double angle formula to a power reduction formula. Is it easier to memorize? Not for me. It's easier to know what I can get from here to here by pushing around the algebra. Is the algebra easy? No. It's kind of a pain. It takes a lot of paper, but hey, it's part of the work we got to do. So that's the power reduction formula. How would this be useful? Well, let's say you didn't have cosine squared. You could put it in terms of something else. Again, in the days before calculators and you couldn't square a hard number to square, it might have been easier to do cosine 2u instead of cosine squared. That's really what it is. Let me show you the last little bit of information here, then to get you from there to there. If you didn't want to have cosine squared, you could do this, and we're going to do 2 steps and we'll get the half angle formulas out of here. So you won't even have to memorize half angle formulas either. So first thing is to square root both sides. Now when you square root both sides, the problem is you have to remember also that you got a plus minus in there. Don't worry about that too much. A little side note here, whoops. But anytime you square root both sides, you got to worry about the plus minus. Finally then, this cancels that. So now you're back to just cosine of u is equal to this crazy mess here. Rewrite that. And that crazy mess now looks like that. Now we're going to go one step further, so let me transfer this to a new sheet. So there it is. Now the half angle formula just starts from this premise that we've just pushed our way through, and says instead of that, let's replace it with u over 2. So instead of this, instead of u, let's replace it with u over 2. It's like a substitution, because we could plug in x, we could plug in y, now it's changing the variable. So we'd have 1 plus cosine of 2, but instead of u, we're going to put u over 2. All right, don't worry, this will make sense in a second. And what happens is 2 times u over 2, 2 times a half, and basically those cancel. You get plus or minus this thing. And now you have this thing. So you're like, whoa. Okay, so this is your half angle formula that you don't have to memorize as long as you remember all these steps that we did all here. Okay, so you can work your way through it. You can push around the algebra. It is definitely not easy. But what it is sort of, why would you want to do that? Well, it's good practice. It's a lot of algebra steps. It's good practice for that. But again, back in the old days, if they said, Johnny, what's the cosine of 22.5 degrees? And I said, I don't know. But I know 45, because 45 comes in a standard triangle. And you can put 45 degrees in here and crank the rest of this out. Okay. And you'd have 1 plus cosine of 45 over 2. And this would be positive because cosine would be in positive. 45 would be the first quadrant. So that's where that plus minus came in. Cosine of 45, that's the rad 2 over 2. And then over 2. So we still got some work to do here simplifying fractions. And I will leave that to you. This has to be then gotten to a common fraction. Well, let's go ahead and do it together. I'm not going to lead. We went this far together. Let's not lead it to it. You can pause it here and do it yourself, or let's see what we get. 1 is going to become 2 over 2, which becomes 2 over 2 plus rad 2 over 2, which becomes plus rad 2 over 2. That's the top part. And then you still have an over 2, and that's okay. And we're going to write this 2 as a 2 over 1. So now we have a fraction over a fraction. This is definitely a complex fraction. Don't worry, we can do this. Moving to the side, we will get 2 plus rad 2 over 2 times, and we reciprocal that one. That's 1 over 2. So it's not that bad at all, really. That's 2 plus rad 2 over 4 now. Don't reduce these because you can't reduce those, and then you'll leave it as that. 2 plus rad 2 over 4. All that work to get that. And again, in the days before calculators, this is how you had to do it. And even though your calculator can give you a decimal answer, it's an approximation. This is exact, because these square roots are funky little beasts. These are never-ending decimals. That is not a natural number. That's not a rational number. That is totally irrational. And thanks for watching, guys. You stuck around to the end. That's not irrational. That's a totally irrational thing to do. Thank you for watching. I appreciate it, and we'll see you next time.